Vectors are quantities that tell us how big something is and which way it points. Adding them is a simple rule, and civil engineers employ it to check if a structure is stable. On the flat two-dimension plane, we take two arrows, A and B. We will slide B so its tail meets the tip of A. The arrow from the origin to the final tip is the sum. This visual move is the same as adding the components of each arrow. In 3 dimensions, the intuition does not change. There is simply one more number to add. Rotate the view and notice how vectors are present in the 3-dimension plane. The dimensions are different and the values have another dimension after addition. We will again slide vector B so its tail meets the tip of A. The arrow from the origin to the final tip is the sum. The equation shown on screen is the way vector addition is carried out. It is just simple addition done thrice. We hope a good level of understanding is achieved on how vector additions are carried out. We can now move on to the application part of vector addition. Vector addition finds application in all fields of engineering. Today we have chosen the domain of structural engineering. Truss analysis is a key principle in structural engineering that allows engineers to determine the internal forces and stresses acting within a truss system. A truss system is a framework made up of members, usually arranged in interconnected triangles, that are joined at their ends. The triangular arrangement makes the structure stable and efficient at carrying loads. In the truss example, a downward load at the top joint is carried by 2 angled members. Each force can be split into a horizontal part and a vertical part. To conclude this video, force is a quantity with both magnitude and vector. That is, force is a vector quantity. To obey the principle of equilibrium, the sum of all forces should add to 0. If it does not equal to 0, then the system is not in equilibrium. Now the components of forces act horizontally and vertically. The forces acting along the x-axis and y-axis is nothing but the product of forces times the cosine and sine of the angle along which it acts respectively. We need to apply this analysis to each joint systematically and later solve and derive for unknown forces. Truss analysis finds application not just during construction of buildings but also for aircrafts, cranes, and other structures. With this video, we hope you reached some level of understanding. See you in the next video.